es Becka.
Mi nombre es Pablo.
My name's Sam.
Thanks for watching us on DPS TV.
Okay, so today we're going to talk a little bit about net atomic charge. That word net really means overall. So what we're interested in is the overall charge of an atom, whether it's more positive or more negative. And so to think about the overall charge of an atom, we have to sort of think about the parts of an atom. So let's just draw a basic diagram of an atom here. Okay, so at the center of the atom, we have something called the nucleus. A nucleus is made up of protons and neutrons, so I'll put a P and an N in the nucleus there. Nucleus. And again, that's just a region at the center of an atom. And then around the outside of an atom, or the outside of the nucleus, excuse me, we have what are called orbitals, electron orbitals, which are regions of space where electrons exist. All right, so there we go. There's some electrons. And this is an orbital here. Okay, so again, there are three subatomic particles. There are electrons, protons, and neutrons. But when we think about the charge of an atom, all we're really concerned with are the protons and the electrons, because neutrons, well, they do provide mass, and we did another video on mass, which you can check out if you want to know about atomic mass. But while neutrons do provide mass, they do not have any kind of a charge. Their name, in fact, neutrons, comes from the word neutral, which just means having no charge. So we're just interested then in the protons and the electrons, which each of those subatomic particles provide charge. So protons have a positive charge. I'll put a little plus next to our protons. It looks kind of like a T, sorry. And I'll put a little minus sign next to one of our electrons. So protons have a positive charge, electrons have a negative charge. And what we're really trying to do when we find net atomic charge is just figure out what's the difference between the number of protons and neutrons. Are there more protons, in which case you would have a positively charged atom? Or are there more neutrons, in which case, or excuse me, electrons, in which case you would have a negatively charged atom? All right, so let's erase this example atom and let's look at a real life example. So I like to use the website ptable.com as a periodic table that I use in class. It's really neat and it's interactive and it's free to use. So let's look at the element oxygen. Oxygen is a good atom to think about in terms of it having a net charge, because oxygen actually naturally, or oftentimes, oxygen in an environment will have a negative charge if it's just a single atom. So if we look at the symbol for oxygen, and I'll draw one quickly here. Let me make the thickness of this line a little narrower. Okay. So on the periodic table, the box for oxygen is like this. It's got an 8 at the top, an O for the symbol for oxygen, oxygen, and then the number listed down here is 15.99. Now that's the atomic mass. And again, we covered that in another video, so if you're interested in learning how to calculate atomic mass, check out that video. But the number that really interests us right now, or for this video, is this number, which is the atomic number. The atomic number always tells us the number of protons in an atom. So in an atom of oxygen, we are always going to have 8 protons. So over here, let's just draw a diagram of an atom of oxygen. Okay, so here's the nucleus with 8 protons. I'll put a plus. And the most common isotope of oxygen has 8 neutrons. If you're interested in learning what an isotope is, check out that other video. 8 and for neutrons. Okay, so that's the nucleus of the atom. And then around the outside, in a typical atom, anytime in a standard atom, I should say. In a standard atom, there's always going to be the same number of electrons as protons. And let me explain why that is. Let me draw in some electrons. So as I said, electrons occupy regions called orbitals. And you can see I'm organizing these 2 in the center orbital, and then I'm going to put the remaining 6 on the outer orbital here. And the number of electrons that go in an orbital is another important concept in chemistry and biology, and that's something that we'll cover in a future video. But for now, hopefully you can see that I've got 2 electron orbitals with 8 electrons in those orbitals. Remember, each electron has a negative charge. And in my nucleus of this oxygen atom, I have 8 protons, which each have a positive charge. In this case, 8 protons, positively charged, and 8 electrons, negatively charged, each cancel each other out, and so the net charge of this oxygen atom, the net charge is equal to 0. Again, because I have the same number of protons as electrons. They cancel each other out. But let's imagine a situation where oxygen actually gains electrons. So this is something that oxygen does fairly frequently. It's a natural thing for oxygen to do. So let's imagine that oxygen gained 2 more electrons, which is the standard number that oxygen tends to like to gain. Those 2 electrons are both negatively charged. And so, since we have now 2 more negative particles than we have positive particles, again, if you're keeping score, we have 8 protons with a positive charge and 10 electrons with a negative charge. We have 2 more negative charges than positive charges. And so now the net charge of this atom is not 0, but -2. And in fact, this is no longer an atom, but it's actually now called an ion. So technically, an atom is only going to be an atom if it has a neutral charge, a net charge of 0. If it has a positive or negative charge, it becomes an ion. In this case, it has a negative charge, so it's a special kind of an ion called an anion. So I'll write that down here. Anion. Let's look at just one more example of this so that we get a complete understanding. Let's erase this oxygen atom, net charge over here, and let's get rid of this symbol. Let's pick a different element off of the periodic table. So another one that's good to think about net charge with is sodium. Okay, so sodium has the atomic number 11, and it has an atomic mass number of 22.990. So I'll just make that symbol for us really quickly. Okay, so sodium, oops, click off that. And sodium's atomic symbol is Na. And you may wonder, why is sodium, which starts with SO, abbreviated Na? And that's because a lot of the names for the elements actually come from the Latin name for those elements, and the Latin name for sodium is natrium. So that's the reason for that. Okay, so I think it was 22.99 was the atomic mass number. Again, atomic mass is not what we're interested in. Here, what we're interested in is the atomic number, because the atomic number tells me the number of protons in a sodium atom. So let me really quickly, All right, so sodium has 11 protons, and the protons have a positive charge. And it has, let's see, 12 neutrons in its most common isotope. Again, check out that video on mass and isotopes. Okay, so sodium actually has 3 electron orbitals. Sorry, my circles are not very good here. They're very hard to freehand. Oh gosh, that's not very good. Okay, so sodium has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 electrons. So sodium has 2 electrons in its first orbital, 8 electrons in its second orbital, and 1 electron in its third orbital. And again, if you're interested in why certain orbitals take a certain number of electrons, that's something that we'll cover in another video. But for now, just bear with me that there is just that 1 electron in sodium's outer orbital. And sodium, because of its nature, tends to like to give up that extra electron. So let's imagine a situation where sodium gives up that extra electron. I'm just going to go in here and I'm going to erase that outer orbital. Okay, so here's sodium, and I know my drawing is not super clear, but you can hopefully see that there are 11 protons in the sodium atom and only 10 electrons. So let me just write that over here to the side. 11 protons and only 10 electrons. Net charge is always the difference between the number of electrons and protons. And whether it's positive or negative is going to depend on whether we have more positive particles or negative particles. So in this case, we have 11 protons, 10 electrons. So we have 11 positive particles, 10 negative particles. So the net charge of this atom, the net charge of this atom is going to be equal to +1. And again, it's no longer going to be an atom. It's now an ion because that has a charge. But since it's a positive ion, not a negative ion, remember that negative oxygen ion was called an anion. This positive sodium ion is going to be called a cation. So cations are positive and anions are negative, and that can be a little tricky to remember. A good clue or a good hint for remembering that is that cations, right, are positive, and cats have paws, right? So cations are positive. Anyways, that's kind of a silly trick to help remember, but it's a good way to remember. Hopefully this video clears up a little bit the idea of what net atomic charge is.